Hey Math 20-3 and welcome to 3.3. Now we're going to be dealing with something called volume, and then this thing called volume relates to something else called capacity. So if you guys look back at your formula sheet, I don't know what that was, we've been dealing with area so far. So that was all these ones, and now we're going to be dealing with the bottom ones here, so volume. Volume is actually going to be a lot easier, to tell you the truth, because surface area we had to kind of break it down into one end or all the different parts of it. This one's pretty much just use the right formula. Okay, so volume is a measure of the space a three-dimensional object occupies. Capacity means how much stuff can you actually put in there. And in case of stuff, we're usually going to be talking about water. How much water can you put in there? So, so what we're gonna find is once we find the volume of some kind of shape, we're gonna be able to figure out how much water you could put in, because I know that 1 liter of water is equal to 1,000 centimeters cubed. So this one is volume, this one is capacity. So we just have to switch from one to the other. All we're really gonna do is divide our answer by 1,000 when we get there. But anyway, I'll give you an example to show you. So here's example one. You can look through that one. It's already kind of done here for you to kind of give you an idea. But let's start on number one here. Okay, so it says find the volume and capacity of the following rectangular prisms. So the volume of a rectangular prism, looking at your formula sheet, volume is equal to length times width times height, which is equal to area of the base times height. I'll show you what I mean by that. So if you were going to sketch this out or draw it, I'll show you a little quick way to make a drawing of it. So make a rectangle, then make another rectangle kind of just offset with that one, and then connect all the corners. And you can see that I've kind of turned that into a three-dimensional shape. And then this one's saying the base of this thing is going to be 15.7 centimeters. It's going to be 18.8 centimeters. And then it's going to be up 12.5 centimeters. So those are all my dimensions. So if I want to figure out the volume of this, you just multiply all those things together. So volume is going to be length times width times height. But then why did this thing say area of the base times height, or AB times height? Well, the reason for that is because the area of the base, the area of the bottom of this, that is just 15.7 times 8.8. So they mean the same thing. I'd get there the same way. If I found the area of the base, I'd go 15.7 times 18.8, and then multiply that by the height of it, or just use the formula, just that times that times that, the whole thing all together. So anyway, the volume of this is going to be 15.7 times 18.8 times 12.5. So the volume is going to be equal to 3,690. And the units for volume are centimeters cubed, because there's three things you're multiplying by, three dimensions there. Okay, so that's my volume. So I found the volume. Now to find the capacity, remember I said that the capacity is how much water can go in. Well, I know that in 1 liter of water, there are 1,000 centimeters cubed. So all I need to do is take my answer in volume there and divide by 1,000. So I'm just going to go, so to find my capacity, I'm just going to go 3,690 centimeters cubed and divide that by 1,000. And that's going to give me 3.69 liters. You can see that I've really just moved the decimal place over 3 times. It was on the end, and I moved it 3 times over. It's going to be that easy. Whenever it says find capacity, that's pretty much what we're going to do. Okay, part B. The base is a square with sides 2.7, and the height is 4.5. But you might say on your formula sheet, well, there's 3 things to multiply by there: length times width times height, right? But I've only got 2 numbers here. Well, that's because this is a square, so I've got the bottom of my rectangle is the same size, right? Oh, that's wrong. So it's more like a square size. So in this case, Like this is 2.75, and so is this. This is also, I forgot to do that one, 2.75. And then the height of this is going to be 4.5. So I just need to multiply them all together. So V is equal to 2.75 times 2.75 times 4.5. So V is going to be equal to 34.0 meters cubed. Okay, I'm actually not going to make you guys figure out the capacity on this one, though. Just it's a little bit kind of funny. So that'd be good enough on that one. For part C, if we're going to figure out this one, what I'd recommend doing, though, is what we're going to do is change these fractions. So we got like 1.5, we got 3 3/4, we got 2 1/4. Write those as decimals. And if you're not sure what that is as a decimal, literally just do it in your calculator. So you can probably figure out that, 1.5, that's 1.5 inches. 3 3/4, well, let's say you forgot what 3/4 was as a decimal. If you literally in your calculator just go 3 divided by 4, it's 0.75. So this would be 3.75 inches. And then this one would be 2.25 inches. Okay, and then when you got that, it's just going to be your normal formula, right? So just V is equal to length times width times height. Okay, so I'll let you guys go ahead and answer that one now. Okay, moving on. Okay, now we're going to have these type of ones. So it says a rectangular prism has a base of that by that. And this time it gives you the volume. And it says, what is the height of the prism? So let's start off with our formula. So the formula is volume is equal to length times width times height. And now what we're going to do is we're going to fill stuff in as we know it. Okay, so we know the volume this time. This time it didn't give us the sides. It gave us like the answer. So I'm going to write 142 in place of the volume. So 142. Okay, and then I'm going to fill in some other stuff as I know it. So we also know the base of this thing is 5.2, so that's probably the length, and then by 7.8, so the width. So we know those two things. So this is going to be 5.2 times 7.8, and then times your height. And we need to find the height. So I'm going to do one more little step here to make things a little bit easier. Is this 5.2 and the 7.8? I'm actually just going to multiply those right now together. So we can just kind of rewrite this again. So I'm going to go 142 is equal to, and then 5.2 times 7.8. That's equal to 40.56. So 40.56 times h. Now, I just need h on its own, right? So right now this 40.56 is kind of in the way. So what I'm going to do is I'm going to, you always do the opposite of what's being done. So right now I'm multiplying 40.56. So I'm going to divide 40.56. But whatever you do to one side, you do it to the other. So we're going to divide both sides by 40.56. And the reason why we did that is because now if I have 40.56 on this side and on this side, I can cancel those. They cancel. And I'm just left with h on this side of the equation. So in the end, I've got h is just going to be equal to, here, I'm just going to finish writing this up here. I've got 142 over 40.56 is equal to h. So then I'm just going to go 142 divided by 40.56. So 3.5. So the height here is going to be 3.5. And then just go back and make sure you got the right unit. So 3.5 meters. And then circle your answer. Okay. Number 3. One rectangular prism has dimensions of 18 by 12 by 32. A second prism has a base that is 14 by 20. Approximately what must be the height, or its height, approximately what must its height be if it has the same volume as the first prism? So pretty much like the question above, but what we got to do first is figure out what the volume of the first prism is. Well, that's easy enough. I just need to multiply all those numbers together. So here, I'll do the first prism in blue. So volume 1 for the first prism, we'll say is equal to 18 times 12 times 32. That's just length times width times height, right? So V1 is going to be 18 times 12 times 32. So 6,912. 912 centimeters cubed. Okay, I'm going to put a little box around that to show that we need that for later. Now it says what must the height be of the second one. I'll do the second one in red maybe. So now let's go for our second prism here. So let's go V2. So just for the second prism is what that 2 is equal to length times width times height. But now we know what V2 is, right? That's this. We want it to be the same as the first one. So we're just going to put that number in place. So I'm going to put in 6,912 is equal to, it's given us the length, it's given us the width. So we're going to go 14 times 20 times the height. And now we're looking for the height. So remember, just like the one in the last one, remember what we did here. We just multiplied those to kind of make it a little bit easier, right? We're just going to be able to simplify that a bit. So let's rewrite this again and go, okay, 6, 9, 12 is equal to 14 times 20 is 280 times h. And instead of times h, what we do is just write it beside it. So I'm just going to start getting used to just writing h like that. That means times, that they're written beside each other. So now we're going to just divide both sides by 280. So if I divide this side by 280, then I divide this side by 280. You have to do the same to both sides of the equation, right? So then we just get h is equal to 6,912 divided by 280 is equal to 24.7. And that was in centimeters. All right, moving on. Come on. All right. Okay, so for number 4, I'm going to kind of maybe set it up for you a bit here. So we've got again, just the rectangular prism we're saying. In this case, though, let's say that this is like a hole. I don't know how to really draw this the best way. Say this is the ground, right? That you've kind of got up here. Hopefully this works. Yeah, this is going to work. Okay, so that's what you're driving on. Hopefully that makes sense. So if I got a truck up here, so there's a truck. Pretend that's a truck. Okay. With that truck, I've got a hole down here, and it's like underground, right? It's still a rectangular prism, but it's going to be under the ground like that. This hole that we dug is going to be 35 meters by 25 meters, and then it's going to be 12 meters deep. So 12 meters, that's this up and down, right? And it says how many trips will be required to remove the dirt if a trailer can carry only 15 cubic meters of dirt. So really all we're going to do is the same thing, just figure out what your volume is in that prism, just like what we've been doing. And then you know that 15 cubic meters can get taken away in every trip. So all you got to do is divide by. So whatever we get for volume, divide that by 15 cubic meters, and then you'll end up with how many trips you could actually take. Okay, so I'm going to let you guys do that. So go ahead and answer number 4 now. Okay, moving on. Okay, example 3. Now what we're going to do, you can kind of see that we've got these, they're called composite shapes, right? Like what we did in the last one. where we need to kind of figure out what the volume is something that's not just a perfect prism like that. So example 3 has a solution right here that you can look through to make sure that you got that figured out. I'll actually let you guys skip number 5, and we'll go just actually straight into the questions starting at number 6 here. So this one says, find the volume of this figure. So now what we want to do with these questions is we want to break this up into different parts. So we could break it up into 3 rectangles or 3 prisms like that, right? And I could find out like this one, and this one. Or make it a little bit easier than that even. We could break it into a prism like this, right? From there to there. And then find the volume of this one and find the volume of this one. Okay, so let's find the volume of the bottom one first because I think it'll be just a little bit easier. So I'll make that one orange. So that this will be block 1 or prism 1 that we're going to find. So we just need to make sure we know where our sides are. So remember volume, we'll call that volume 1 for, this will be our, volume 1 is equal to length times width times height. Okay, now the length of this thing is 30. So let's just fill it in. So V1 is equal to 30 times. Now the width of this thing is 12, right? That's how far this way it goes. So that's 12. So I'm figuring this out pretty easily so far. And then times, well, the height of this bottom one is just 8. So that was pretty straightforward. So we just need to say V1 is equal to 30 times 12 times 8. 2,880. And that's meters cubed. Okay, I'm going to put a little box around that to show that we need that. We're going to have to add that to whatever the volume of this other one is. So I'm going to make this one now V2, to the volume of this top box. So this one we have to kind of figure out a little bit more. What is the bottom here? What's our width? Well, we can figure out that width pretty easily. If we kind of look at this and say, okay, well, it's 30 from there to there. And I know it's 9 from there to there and there to there. So if I go 30 and I subtract this 9 and then subtract this 9 as well, so 30 minus 9 and then minus 9 again, I should end up with just this from there to there, right? So let's go 30 minus 9 is 21, and then just minus 9 again. I'm left with 12. So I now know that from here to here is 12. Okay, so now I know that. Now the rest of it should be pretty straightforward. So I'll go V2 is equal to our length times width times height. So V2 is going to be, well, our length is 12. Our width, well, it's not actually drawn right here, but our width is the same as the one down here. It's 12, right? It's down there. So that's going to be 12 as well. And then our height is actually just drawn right on here. That's the 11. It's saying it's 11 high. So that times 11. So V2 is going to be equal to 12 times 12 times 11 is 1,584 meters cubed. Okay, and then last thing we're going to do, we are just going to add both those together. So the total volume, maybe VT you might call it, is equal to 2,880, that's an 8, meters cubed, plus 1,584 meters cubed. So the total volume is that plus 2,880, 4,464 meters cubed. All right, and then circle it. Okay, number 7. Okay, and we are going to take off number 7 too. Let's, yeah, that one's quite a bit too difficult, I think. Let's go on to 50, or yeah, sorry, let's go on to page number 77 of your book. Now, we're going to be moving on to volume of a cylinder. So if you go back to your formula sheet, oh, why does it keep doing that? Anyway, It's right here. So volume of a cylinder is going to be V is equal to pi times r squared times h. Okay, and that's it. We just really need that formula. So we go back here. You can look through that one if you like, but let's just jump into the next one maybe. So it says calculate the volume and capacity of a cylinder with a diameter of 15 centimeters, and diameter is a key word there, and a height of 63. So let's go back to our formula sheet. Volume of a cylinder is V is equal to pi r squared times h. So I'm going to write that down. V is equal to pi r squared times h. Okay, so this said diameter is equal to 15. Well, diameter, we've got this is a terrible cylinder, I know, but it's just doing it quick. Diameter is the whole way from there to there, right? That's the diameter from there to there. Radius is half of that. Radius is just from there to the outside. So we need half of that. So we're just going to go 15 divided by 2. So this is 7.5 centimeters, or r would be equal to. Okay, and then we know the height is just 36. So I'm just going to plug it in. V is equal to pi times 7.5. Don't forget to square it. And then times the height. So times 36. I'll put a little, it's like a dot there to show like times. Okay, so then putting that in your calculator, you would just go hit your pi button. Pi times 7.5 squared. So mine looks like this on my calculator, x to the 2, right? So squared times 36. And then push equals. So 6,361.7. I already forgot. 6,361.7 centimeters and cubed because it's a volume. Okay, that's it. Ooh, sorry, that's actually not completely it because I forgot about the capacity part. So this was the volume that we found. So remember, if you want to figure out capacity, there in 1 liter, there is 1,000 centimeters. So all I need to do is divide this number by 1,000. So my capacity would be 6.36 liters. So that'd be that's it. You just need to divide that by that. Okay, this one, we've really just got 3 of them that we're going to add together. So let's figure out the volume of that one, and that one. So I'll even do a different color. So I'll make the top one purple maybe. So we'll say the volume of that one is going to be equal to pi r squared times h. And remember here, it says the height of each one of these is 20 high. So that's what h is going to be in all of them. So for the first one, V1, that's going to be equal to pi times, well, not 10, but 5, because I want just the radius. So 5 squared times h. So V1, oh, and instead of h, I should have wrote 20 in there, sorry. 20. So then V1 is going to be equal to 1,570.8 centimeters cubed. Okay, I'm going to put a box around that so I can leave it for later. Okay, so we got this one figured. Now we're just going to move on to the middle one. So that's going to be V2. It's going to be pi times, but this time it's going to be 10 squared times 20. So V2 is going to be 6,283.2 centimeters cubed. And I need that for later. And then lastly, our last one's going to be, so V3 is equal to pi times, this time the radius is going to be half of 40, so 20 squared times 20 for the height. And then, so V3 is going to be 2,000, or 25,000, sorry. 25,132.7 centimeters cubed. Okay, and then all we got to do is add all those things up. So add that one, and that one. If you do that, you should end up getting a final, so just say add them. And then you'd end up getting V, total maybe for all of them, would be equal to 32,987 centimeters cubed. Okay, and then lastly it says what's the capacity. I just need to divide this by 1,000. So this would end up being, so capacity, let's say C, is going to just be equal to 32.987 liters, which you might round to just 33 liters. All right, moving on. Okay, so number 10 here says a large tin can has a capacity of 3.24 liters. If the can has a diameter of 15.56 centimeters, what is the height of the can? So let's draw our can. So we've got that, right? Now, what we need to figure out, so we're really after this formula, right? V is equal to length, or sorry, V is equal to pi r squared times h. Okay, and we don't really even know the volume yet because they've just given us the capacity in liters. So let's change that into volume. And the way we do that is instead of just dividing like 1,000 like we've been doing, we're going to just multiply by 1,000. So that's going to give us 3,240 centimeters cubed. So that is our volume. We just multiplied that by 1,000 to get back to centimeters cubed. Okay, so now I'm going to put this in for volume right now. So we know volume is that number. It's 3,240. And that's going to be equal to, well, pi is just a number, so I'm going to write that down. It also tells us the radius. Well, not directly. It tells us the diameter, but I know the radius is just half of this. So I'm going to go 15.56 divided by 2. And that gives me 7.78 for the radius. So we're going to go 7.78, and then that's squared, don't forget that, and then times the height. And that's what we're looking for, is the height, right? So now we just need to solve for this. What I'm going to suggest to do that's going to make things a little bit easier, I'm just going to write this again, 3,240. And now I'm actually just going to multiply these things all together so I can get just a number. So let's go pi. Let's start over. I'll make sure I didn't have anything in there. So pi times 7.78 squared, and then don't forget to push enter to figure out what that is. So 190.16. So that's what that stuff in there all together was, right? And then it's that times the height. Okay, so then if I want h on its own, I'm just going to divide both sides by that, by 190.16. Those cancel. 190.16. So we end up with height is equal to 3240 divided by 190.16. So 17. And that's your answer. That should have been a decimal there too. So that's your answer there. So 17, and we were measuring it in centimeters. So 17 centimeters. Okay. Right, so I'm actually going to let you guys go ahead and do these ones now. They're just similar ones to the ones we've been doing. So I'll get you guys to go ahead and answer number 1 now. Okay. Number 1B, we're dealing with a cylinder now, so just make sure you got the right formula. So now volume is going to be equal to pi r squared times h. So go ahead and answer B now. Okay, C, it's kind of a combination of the two questions from above now. You've got cylinder, you've got a rectangular prism. We just got to add them together. So figure out the volume of that one, the volume of the bottom one, add them together, that's it. So go ahead and answer C now. Okay, number 2. Which of these figures has the larger capacity? Show your work. Well, capacity doesn't really matter. Whichever one has the biggest volume, that would work too, because if it has a bigger volume, it's going to have a bigger capacity anyway. So I'd just figure out which one of these has a bigger number when you figure out the volume. So you got to figure out the volume of this one, and you got to figure out the volume of this one. And when you're done, just tell me which one's bigger. So go ahead and answer number 2 now. Okay, it says a silo has a diameter of 24 feet and is filled to a height of 70 feet. What's the volume of grain stored in it? So again, it's just a cylinder. Just make sure that you'd recognize that you're dealing with a diameter instead of a radius there. And then, yeah, that's going to be it. So go ahead and answer number 3 now. Okay, number 4 says Graydon is laying a cement patio. It is to be 6 meters long by 4.5 meters wide and 15 centimeters deep. So I'll help you out with this one. I don't want you to get tricked on this one. Those all need to be the same. So this is in centimeters. These two are in meters. What I would do is I would change it into meters instead of centimeters. And the only reason why is because in part B, it asks for like something per cubic meter. So it'll be easier if we change this into meters. So here's the question. How many centimeters are in a meter? And if you're kind of wondering about that, in a meter stick, if you have one at your school, there's 100 centimeters until you get to 1 meter, to the length of that stick, right? So if there's 100, all I need to do is divide that by 100, and that'll give me how many centimeters it is. Another way of doing that is just moving the decimal place from the end of it 2 places over. There's 2 zeros in 100, so you move the decimal place 2 zeros over. Okay, so this would actually be, let's say, 0.15 meters. Okay, so now it's a normal question. You just need to figure out the volume with those 3 things. Okay, so go ahead and answer 4A now. 4B says if concrete weighs approximately that much per cubic meter, how much will the patio concrete weigh? So I'll let you guys see if you can answer that one on your own too. So go ahead and answer 4B now. Okay, so for 5, it says a fish tank in the shape of a rectangular prism. So like the ones we've been drawing, right? So something like that. Contains 15 liters. That's capacity, right? We'd like that to be in centimeters cubed for our equation. So let's change it now. So all you need to do is move the decimal place or multiply by 1,000. So this is going to be 15,000 centimeters cubed. Okay, so now that we know that for the volume, we just need volume is equal to length times width times height. And it wants to know the depth of the tank. Well, that's my height. So we've done a few ones like this. So if you need to, go back and look at your previous questions and see if you can solve for H here. So go ahead and answer number 5 now. Okay, number 6. A large cylindrical fuel storage tank has a capacity of this many liters. If it has a diameter of 2.4 meters, what is the height of the tank? So this one's going to be similar. Let's change liters into centimeters here first. So we need to multiply this, even though it's a big number, we got to multiply it by 1,000. So let's go this times 1,000. That would be, well, just 3 more zeros if you multiply by 1,000. That many centimeters cubed. And then the other little trick that I would do to keep things simple here is this 2.4 that we're dealing with over here. I would change that into centimeters, because then just everything's in centimeters now, and we just do like our normal thing. So to change that into centimeters, There's going to be more centimeters in a meter, right? So I'm going to want this number to get bigger. And remember, there are 100 centimeters in a meter. So you go 2.4 times 100. Or you move the decimal place over twice. So that would be 240 centimeters. Okay, now we just need our formula. So V is equal to pi times r squared times h. Well, we know the diameter was 240. That was the diameter though, right? What do you need to do to that to turn it into radius? So I'll let you figure that one out. And then we've done one like this already too. So just go ahead and you can answer for h. So plug in your giant number over here for your volume, or over here I guess, for your volume. Figure out what pi times r squared is, and then solve for h. Okay, so go ahead and answer number 6 now. Okay, so that's going to be it for that video. And that's it for 3.3. So I'll see you guys in lesson 3.4.